Hello students, let's study about half-life of a reaction. What is meant by half reaction, or how this is going to influence a reaction? What is half-life? The time during which the concentration of reactants is reduced to half of the initial concentration. For example, take this to be the initial concentration. As the reaction proceeds, after some time, say t half or any time, the reaction will reduce. It will reduce to some extent. T half is when it is reduced to half of the initial concentration. This is how we are going to represent half-life of a reaction: the time during which the concentration of the reactants is reduced to half of the initial concentration. It is denoted by T half. So let's see how this is going to affect reaction. We will begin with the half-life of reaction in case of zero order reaction. Half-life of zero order reaction. For in this case, we know the integrated rate equation for zero order reaction is concentration of reactant is equal to concentration of reactant initially minus rate constant into time. This is the equation. Now reaction has proceeded, and at T half means when the time has passed half. So in that case, the concentration of reactant would be half of the concentration of reactant what it was initially. This is initial concentration. This is how it is going to be represented. Now the concentration is equal to half of the initial concentration when the time has passed half. So it can be rewritten as this. In this equation we are going to put this value. This will be half R is equal to minus KT. Now the position will be changed. We will take KT minus KT to the other side, and this will be taken to the other side, and the sign will change as it will become KT equal to initial concentration minus half of initial concentration. Now this time will become half, T half, and in that case this is to be also placed. Now we will subtract this value. Let's make some space. This was our equation. Now this is going to be changed to become a new equation in which we will take initial concentration as common, and then here we will put 1 minus 1 by 2. So this will become 1 by 2, and we have T half half time period equal to half of initial concentration. This will be placed here, and then we have 2k. This is T half for a zero order reaction, and it is visible that the initial concentration plays an important role in this case, which means that T half is proportional to initial concentration. Now let's see half-life of first order reaction. For this reaction, we know the rate equation is K equal to 2.303 divided by T log initial concentration divided by final concentration. This is initial and this is final. Now if the reaction has proceeded to a certain extent, then this is going to change. This equation will change. After T half, it will reduce to half. Now let's slightly modify this equation. Instead of K, move this T over here and this K over here. We have this equation, initial upon final. Now the statement once again is, when T is equal to T half time has passed after the after the reaction has started, then the concentration, new concentration, would be half of initial concentration. So this value is going to be placed over here, and the equation will be rewritten as, in case of T half, (2.303 by K), and then we have log initial concentration of reactants by 1/2 this is going to become, and we will cancel these common values. 2 will be placed over here, and the equation would become T half equal to 2.303 upon K and log 2. The value of log 2 will be placed over here. In that case, 2.303 by K will be multiplied by 0. The value of log 2 is 0.3010. Now if it is multiplied by this value, the T half equation would become 0.693 by K. This is equation, T half equation for first order reaction. Now this equation shows something special. We do not have any concentration term over here. We do not have initial concentration over here. That means half-life period for first order reaction does not depend upon initial concentration of the reactants, because we do not have such values. We do not have this value in the equation. That means this doesn't depends on initial concentration of um, reactants in case of first order reaction.